Remember that there are three primary ways X radiation can interact in the human body: the photoelectric effect, coherent scattering, and finally Compton scattering. The focus of this lesson is Compton scattering. Compton scattering is extremely significant in medical imaging. It's the most common radiation interaction at most energy levels. It affects the radiation dose to patients, it affects the radiation dose to X-ray techs, and it affects radiography image quality. And of course, none of these effects are good effects. So what is Compton scattering and how does it work? Like all X-ray interactions, Compton scattering can happen when an X-ray photon leaves the X-ray tube and enters the patient's body. This incident photon collides with an electron, usually a loosely bound outer shell electron. Two things happen as a result of this collision. First, the electron is ejected out of orbit, a process called ionization, and then secondly, the photon decreases in energy and changes direction, called scattering. In fact, that's why this interaction is called scattering. The photon is scattered off of its original path. The difference between Compton scattering and photoelectric effect is actually pretty simple. With the photoelectric effect, the incoming photon is actually completely absorbed by an inner shell electron. The electron is ejected out of the atom, but there's no scatter photon. With Compton scattering, the energy of the incoming photon is only partially absorbed by an outer shell electron. The electron is knocked out of the atom, but a scatter photon also comes out of the atom. Basically, photoelectric effect results in only an ionized electron, but Compton scattering results in an ionized electron and a scatter photon. So what happens to the scatter photon and the ejected electron? The destination of these two products is what makes Compton scattering so significant. The ejected electron is eventually absorbed by the patient's body, which is why Compton scattering does affect the patient's radiation dose. A lot of things can happen to the scattered photon. It may also be absorbed by the patient's body and increase the patient's dose. This photon might also be scattered out of the patient's body and towards the radiographer. This is why Compton scattering is the most important source of occupational dose. And then finally, the scattered photon might be scattered out of the patient and towards the receptor. Compton scattering photons decrease image quality by decreasing image contrast. The use of radiographic grids help to prevent scattered photons from reaching the receptor. There are specific terms used to describe the direction of the scattered photon. Compton photons that are scattered towards the receptor are called forward scatter or small angle scatter. Photons that are scattered back towards the X-ray tube are obviously called back scatter or large angle scatter. And finally, photons scattered perpendicular to the path of the original main beam is called side scatter. The direction of the scattered photon actually affects its energy. Back scattered photons have the lowest energy, and forward scattered photons tend to have the highest energy. There are a few things that affect the amount of Compton scattering and the direction of Compton scattering. Increasing patient thickness increases the number of Compton interactions taking place in the body. Maybe you've heard the saying, more matter, more scatter. That's true. The more scatter produced, the more scatter will be on the image. Increasing the field size or the receptor size also increases the number of scattered photons reaching the receptor. And then finally, increasing kVp doesn't really affect the amount of scatter being produced, but it does cause more of the Compton photons to be scattered towards the image receptor. That's forward scatter. That's part of the reason why increasing kVp actually decreases contrast. More kVp means more scatter on the image receptor. So to keep Compton scattering to a minimum, the X-ray technologist should use a low kVp, a small receptor size, and only take X-rays of small patients. So in summary, Compton scattering is the most common of the three main X-ray interactions. Also, this interaction results in a scattered photon and an ionized electron. Lastly, we should remember that Compton scattering affects patient dose, occupational dose, and decreases image quality.